All right, so here's the last part. Here's another application of exponential functions. We can have increasing and decreasing exponential functions. So remember, increasing means the base of our exponential function is greater than 1. Decreasing means it's a fraction between 0 and 1. All right, so they can be used in a variety of real-world applications. For example, population growth. So if you're in a science field, you'll probably see population growth being modeled by an exponential function. The growth of an investment under compound interest increases exponentially. The mass of a radioactive substance can decrease exponentially with time. So we're going to talk about that last case. All right, so if you're a biology major, you probably know a little something about half-life. It can be a little confusing to talk about, but we use exponentials to model half-life. All right, so it says a substance that undergoes radioactive decay is said to be radioactive, and the half-life of a radioactive substance is the amount of time it takes for 1/2 of the original amount of substance to change into something else. Right, so this thing is decaying. All right, so here's number 7, our example. It says the half-life, so one thing, half-life is time. Half-life is actual time for half of it to go away. All right, so the half-life of radium-266 is 1620 years. In a sample originally having 1 gram of radium-226, the amount in grams of radium-226 present after t years, so our ending amount is given by this formula. So note this is an exponential function. 1/2 is our base, and our power is t raised to the is t divided by 1620. So where t is the time in years at the start of the experiment. So the question is, how much radium will be present after 30 to 40 years, so 3,240 years. So this is our time. Okay, so we can plug that straight in to our function. So our ending amount after this long will be 1/2 raised to our time divided by 1620. All right, so we just plugged in t here. All right, when we do this division, you get 2. And 1/2 squared is 1/4. All right, so what does this mean? It means that after 3,240 years, 1/4 of the original amount remains. Oh, sorry, you couldn't see all of that. All right, so if you know a little something about half-lives, we can see that it's gone through 2 half-lives. So I won't test you on what half-life means right now, but since 3,240 divided by 1620 is 2, we can say that at this time it has gone through 2 half-lives. So it's split in half twice. All right, so the main thing I want you to do is just be able to plug something into an exponential function and get an answer. All right, so here are our learning outcomes. Make sure you can answer yes to these questions. So can you recognize an exponential function graphically and algebraically? Can you evaluate the exponential function base e? So can you find it on your calculator and use it? And are you able to use exponential functions in compound interest and growth decay problems? So if you have questions about any of this stuff, feel free to ask me in class. All right, and that's all.